All right, Ms. Whitaker here, and I wanted to go over some of the graphs that you're going to be doing on your homework tonight. First off, we're going to look at double bar graphs. You know what a bar graph looks like. It is a graph that uses bars to compare data, but in this case we have a double bar graph. So we're going to look at two sets of data side by side when we're comparing. It also says you can organize data using a frequency table, and organize is your key word. There's no trick to it. There's really no math involved. It's just organizing it to show frequency for your data. How many times does this data occur? So that's what a frequency table is going to help us do. So let's look at an example. It says the following are the number of books read in 1 month by some boys and girls in 8th grade. So we've got this table here that shows books read in this row right here. For 0 books, we've got 2 boys and 2 girls read 0 books. For 1 book, well, that happened 3 times for the boys and 1 for the girls. For 2 books, 3 for the boys, 2 for the girls. All right, so that's our frequency table. Let's translate that into a double bar graph. It says the frequencies are going to be the heights of the bars in the graph. And they said here, use a different color to represent each gender, boys and girls. But if you don't have colored pencils or markers, then you could just use, you could do stripes for one of them, and a solid color or polka dots or whatever to distinguish your different sets of data. However, you want to make sure that you have a key that describes each color or each thing that you do to the bars. All right, so it shows our boys are in the light blue here. Looks like we've got everything that we took from our frequency table and translated it over here to our double bar graph. Please notice that your frequencies on the left here, this is books read on the bottom. So our data here is here on the bottom. The frequency is on your y-axis or your vertical scale. So just take a look at that. Make sure you understand. Now also notice that the bars are right next to each other. For 0 books, it was 2 boys, 2 girls. So for 1 book, it was 3 boys and 1 girl. So make sure you know how to interpret the data, but that's your double bar graph. We're comparing boys and girls side by side. All right, let's move on. Just some examples of more double bar graphs. All right, histogram. This might be harder for you. Usually the students have a little bit more difficult time with this histogram. Histogram looks like a bar graph, kind of, and it shows the frequency of data within equal intervals. So intervals is going to be our key word. It's also showing frequency of the data, but intervals is our key word. So when we've got a whole bunch of numbers and we don't want to say, well, this is how many times that 23 showed up to do a bar graph. This is how many times 25 showed up. We may want to do a bar that just represents 20 to 30. So if we have intervals going on, then that's a histogram is what it's going to look like. Another little difference with a histogram is that there are no gaps between the bars. No gaps between the bars. So that's the big difference between a histogram and a bar graph. A histogram is a kind of bar graph, but there are no gaps between where there are with a bar graph, and we have intervals with a histogram. So remember, intervals and no gaps between the bars, and that sets a histogram apart. So let's look at some examples for a histogram. This says Jimmy surveyed 12 children to find out how much money they received from the tooth fairy. Use the data to make a histogram. So we are ranging anywhere from, let's see, my smallest looks like it's about 1/4, and looks like 350. Somebody's getting some bucks from the tooth fairy. So that's our range. So we may want to just say, let's make some intervals of $1. So this says make a frequency table with intervals of $1, then make a histogram. So let's set up our histogram. We'll set up our frequency table first. So from 0 to 99 cents, that happened 4 times. So here's 1, here's 2, 3, and 4. So that happened 4 times. From $1 to $1.99, we've got 1, 2, and 3. From 2 to 299, we've got 1 and 2, and then from 3 to 399, we have 1, 2, and 3. So there's our frequency table. Please notice that our intervals are all equal intervals. It's all dollar intervals, and we're just showing the frequency on the right. So let's turn that into a histogram. Oh, there's our little hint. Histograms do not have spaces or gaps between the bars. So let's look at what that's going to look like. All right, there's our histogram for money given by the Tooth Fairy. Please notice that there are no gaps between the bars, and please notice that we're using intervals of data instead of just one at a time. So again, a histogram is like a bar graph, but no gaps, and it uses intervals for the data. How many times? So if you've got a lot of data, it's probably best to use intervals. You don't want more than 5 bars usually. So if you're finding that you've got 20 bars in a bar graph, go ahead and make intervals and make it a histogram. So hopefully that makes it a little bit more clear. You just don't want a whole bunch of bars, and you don't want a graph that doesn't make much sense. You want one that's easy to read. That's the whole point here. Easy to read and have our data organized nicely. Here's another example. Tanya surveyed 14 children at an after-school daycare to find out how many hours they spend there. So these are hours. We're going to make intervals of 30 minutes. So let's make our frequency table. How many times that time spent at the daycare occurred. Turn that into a histogram. Personally, I don't like this histogram. It's just too boring to me. But anyway, that's their example. So histogram, remember, is a bar graph, uses intervals, and no gaps between the bars. All right, double line graph is used to show how 2 related sets of data change over time. Now, change over time is for line graph, and if you have a double line graph, that means we've got 2 related sets of data that change over time. So let's look at a quick example for this. Make a double line graph of the given data. Use the graph to estimate the number of CDs and DVDs sold in 2003. All right, so this music shop, CD and DVD sales, we have the years on the left, we have CD sold, and we have DVDs sold. And we're going to plot that data on our line graph. Please also notice in a line graph, especially a double line graph, it's important to have a key to show different colors. You could, if you didn't have colors, you could do a solid line and maybe a dotted line. So, but just make sure that your key shows the difference there. Now this is, we're able to see now with DVD sales that they were a lot lower, but they were probably more expensive. See, this is only number sold. This isn't in dollars. So this just is good information for a store owner to know. And also to know that, look, around 2000, then it started going up. So CD sales and DVD sales were going up. So that is a really great graph to show if you're looking at number sold, that how data changes over time. You want to use a line graph because it's very nifty, very handy to see that information right off the bat. Also, please notice if you're going to be constructing graphs, make sure you are labeling both axes and give it a good title, and make sure you have a key in case you need to distinguish that key. Make sure your scale makes sense, your scale over here. Make sure it makes sense. If this was, you know, we have some data that's up here in the 5,000s range, then we don't want to go every 10, right? We don't want to go 10, 20, 30. That would be ridiculous. So make sure your scale is good intervals, because we just want to tell a story with the data. We don't want to bombard somebody with something that just doesn't make a whole lot of sense to look at. All right, so keep that in mind. Hope this clarified anything on especially your histograms. Do your best on the homework, and call me, or not call me, email me if you have any questions.